Hi there, we are today on a beautiful day looking at Leviathan Mine, and with me today is also Kevin Mayer. He's with the EPA. He's going to talk a little history of Leviathan Mine and what we're looking at on the treatment. Kevin?
Well, we're here actually on Leviathan Mine looking at the open pit. This right behind us used to be Leviathan Peak. That high point there was below the peak, another 400 feet high, and that whole mountaintop was broken up and pushed onto the other side of this mountain so that the miners could dig out this big open pit, about 50 acres, and extract the sulfur. They were using sulfur to help copper mine in Yerington. In Yerington, they used 600 tons a day of high-grade sulfur that they extracted from the Leviathan mine. Now, one thing we can see from here is the different colored rocks on the side of the pit there. Those white rocks are bleached from the geothermal activity that put the sulfur and some other minerals in the place here underneath what had been Leviathan Peak. The geothermal activity takes high pressure, and the sulfur comes up from deep in the earth, and as it gets close to the surface, it cools and puts those minerals in the rocks themselves. So down here at my feet is a piece of the rock that was a native rock, and here is elemental sulfur, very high-grade sulfur, and as that sulfur mixes with water and oxygen in the air, it turns into sulfuric acid. And that sulfuric acid is what bleached those rocks and what causes this brightly colored water in this pit here. This pit and these other pits along here were built by the state of California to capture some very acidic and mineral-rich water coming out of this pit area. That water is mostly sulfuric acid at a pH of about 2, whereas neutral is a pH of about 7. And what you're seeing is that the iron that is dissolved with the sulfuric acid turns the water that bright red. Well, the iron is a minor issue compared to the arsenic and the copper and the nickel and the zinc that's also coming out because of the sulfuric acid dissolving those minerals out of the native rock.
You have a canal or channel ice here, that's Leviathan Creek, is that right?
Yes, one of the things that the state of California did in the 1980s was, besides building these pits and terracing these waste rock piles, is that it took the clean water from Leviathan Creek and put it in a concrete channel to keep it away from the sulfur and the minerals, and let that flow through this mine waste and end up in the native creek bed down below the mine. This runs for over a half a mile to get through this waste rock.
Before that, actually, it had huge erosions that would go through and take the sediment and all the tailings.
And collect all the acid that would seep through those rocks too. This looks like solid rock, but actually it's one big tea bag of generating. Instead of tea or coffee, it's generating a toxic mix that we have to capture and treat to keep it away from the Leviathan Creek.
The treatment facilities here is run by which agency?
This is operated by the state of California.
Okay.
This is one of several different configurations of lime treatment. A very standard way of treating acid is to mix it with lime, and that neutralizes it, and it brings the metals out of the water, so the water can be discharged. But it creates one of the many problems that we have to solve here, and that's a sludge. What do you do with the solids that you generate by treating it with the lime? We'll see another lime configuration down below, and they're constructing even a third process to mix lime with the acid and then separate the contaminants, the contaminated solids, from the water so the water can be discharged.
One of the things too you can see is disturbed land here, very little vegetation growing compared to the surrounding area.
That's a very important point, because in order for Leviathan Mine to come back to, and part of the solution, is to revegetate these 250 acres of disturbed area. The state has spent a lot of resources in getting some of these trees and some of this vegetation to grow on what never really was soil. This didn't develop in place here like the slopes we see around us over the many thousands of years with plants and microorganisms generating a nice, rich, even though thin soil. This is just broken up rock. They used many hundreds of pounds of dynamite to create the inside of the mountain to the outside of this, what people might eventually call soil.
Okay. We've now moved to the pit area itself. So Kevin, can you describe what we're seeing in this pit?
Yes, we're in the bottom of the open pit mine. This used to be a little bit deeper. It's been filled in so we don't have a pit lake that would cause even more problems. And it's been terraced a bit and a bit of vegetation after a lot of hard work and experimentation. But this is the 50-acre open pit mine all around the edges here. This used to be well over 400 to 600 feet of mountain up above where I'm standing here. Part of it was pushed off to the Aspen Creek side, and the rest of it was dug out, shipped to Yarrington, or the waste rock that wasn't of high enough grade was just dumped into the Leviathan Creek Canyon. One thing we're seeing right here is one of the ways to deal with separating the clean water, once it's been treated with lime, from the sludge. What I'm holding in my hand here is the sludge. It's lime mixed with sulfuric acid, turns into gypsum, the type of material that you use to a wallboard on your house. Mm-hmm. This is orange because of all the iron in it. But what happens here is that lime is mixed with sulfuric acid, pumped up sulfuric acid from the ponds, and it's pumped up here in a slurry. It's still mostly water, but it's this orange-colored water. And it's put into this pit where the solids settle to the bottom and the clean water flows over into these pipes here. That's tested and then discharged, as if it meets water quality standards, discharged into Leviathan Creek. And then at the end of the year, there's drain pipes underneath here. This U-shaped area, that's a drain pipe covered with sand, and that water drains down into that French drain and then out. It's tested and discharged when it meets water quality standards. But it leaves several inches of sludge. These are a few tons of sludge. Later this year, the contractors will get in here, dig this stuff up, and haul it off to a licensed hazardous waste treatment area. Actually, it's a landfill.
Okay, we're at another location here in Leviathan, and Kevin, can you tell us what we're looking at here?
Well, we're in the middle of the waste rock that was dumped into Leviathan Creek Canyon. And in fact, we're standing on top of a diversion channel that's in two big pipes that run into that diversion channel there. That used to be Leviathan Creek running through here, through what is possibly 100 or more feet of this acidic waste rock. A lot of it's been terraced to stabilize so it doesn't tumble down and degrade the creek anymore. But what we're really seeing here is 2 out of 3 different types of lime treatment that are being tried here at Leviathan Mine. And while they're being tested for their ability to operate over the long term, they're also cleaning up the acid that would, all during the winter, is just going into Leviathan Creek untreated and degrading that water quality. This year, we started treating in May, which is the earliest we've been able to treat. Usually by May, the water in Leviathan Creek has gone way down since all the snow has melted. And as the water level goes down, the acid discharge becomes a larger proportion of Leviathan Creek. And the greater the proportion of Leviathan Creek, that sulfuric acid, the worse it is for Leviathan Creek and everything trying to grow and live downstream for miles and miles and miles. We're about 9 miles away from the East Fork of the Carson River and about 2 or 3 miles away from Bryant Creek, where Leviathan and Mountaineer come together. And that whole 9 miles, when we started here in 2000, that was degraded. There were basically no fish. And now we can bring the fish back at least to the first 6 to 7 miles of Leviathan and Bryant Creek.
The treatment here, how much is this costing?
Well, this is a multi-million-dollar project from the successor to the former mining company, Anaconda Mines. And we're seeing 2 treatment systems, one that's operating, those rotating cylinders, and one that's being constructed in that building that we see that had to be engineered to withstand snow loads, wind loads, winter time. We still have a problem. We can keep the equipment safe, but we can't get people. And what we gear, like the diesel fuel that is needed to run the generators and the lime that's needed to treat the acid, we can't get that up here in the wintertime when there's snow on the road, when the roads are muddy, and that's for most of the year.
Okay, we're now at a new location right below where they have lined Leviathan Creek. And Kevin, tell us what we see here.
Well, there's a lot of work that's represented right here. The most obvious thing is the concrete channel that diverts Leviathan Creek around all the waste rock that is up above us. And this channel takes Leviathan Creek for probably 3/4 of a mile and puts it back in the stream bed right here. But what we also see is this pipe coming out from underneath the channel. And as the state of California was constructing this diversion channel, they kept running into acid seeps that they needed to collect and drain so they could build the concrete channel. This is what we call the channel underdrain, and that is flowing currently about 30 gallons a minute of sulfuric acid solution, somewhat dilute, but it's not good for the creek. And what we see here is that it's being captured, collected, pumped up to the treatment system just above us, mixed with lime, and the sludge separated out, and the clean water eventually will then come back into the creek and provide clean water for Leviathan Creek.
Now this is a situation where, again, it works now, but in the wintertime, that system has to be turned open and the water actually flows into the creek.
Right. When we were up here in April, there was about this much snow right here when we looked on down, and the collection system wasn't operating because the